Hello guys, welcome to my channel. This is second video of our series Nuclear Physics. We are discussing nuclear structure and properties of nuclei. In this video, we will discuss proton-neutron hypothesis, representation of nucleus and some basic properties of nuclei. In the previous video, we have discussed proton-electron hypothesis, and that hypothesis had some limitation which was resolved by proton-neutron hypothesis later on. And here in this video, we will explain how that limitations were resolved. So let us start with our first topic, that is proton-neutron hypothesis. This hypothesis was put forward after the discovery of neutrons in 1932 by Chadwick. The definition of this hypothesis is, according to this hypothesis, a nucleus with mass number A, atomic number Z, contains Z protons and A minus Z neutrons. Since atom is electrically neutral, there should be Z electron as the peripheral electron. So the positive charge of nucleus gets balanced out with negative charge of Z electrons. Let us explain this definition with an example of nitrogen. Nitrogen has mass number equal to 14 and uh, atomic number equal to 7. So it must contain 7 proton and 7 neutron inside the nucleus, because atom is electrically neutral, so there must be 7 electron as peripheral electron or moving around the nucleus. Peripheral electron means electrons moving around the nucleus, so that positive charge of 7 proton inside the nucleus gets balanced out with negative charge of 7 electron outside the nucleus, so that atoms as a whole remain electrically neutral. So let us see how this hypothesis, proton-neutron hypothesis, explained the limitation of proton-electron hypothesis. Explanation of nuclear spin. We will take the example of deuteron. Deuteron has mass number 2 and atomic number 1. So according to this hypothesis, it should have 1 proton and 1 neutron inside the nucleus. So possible spin value of deuteron are, if both the constituents proton and neutrons are in the spin up state, then plus half for proton plus half for neutron, and total will come out 1. If proton is in the up state and neutron in the down state, then plus half for proton and minus half for neutron, and 0 will be the result. And if proton in the down state, then minus half for proton, and neutron is in the up state, then plus half for neutron, and then again result will be 0. If both the constituent proton and neutron are in the down spin state, then both have spin value minus half and total will be minus 1. So possible spin value of deuteron is 1, 0 and minus 1. Also experimentally observed value of spin of deuteron is 1, which was one of the above 3 possibilities. So hence nuclear spin of deuteron was successfully explained by this hypothesis. But in the previous hypothesis, when we considered electron inside the nucleus, then the calculated value of spin were coming half integral spin, but experimentally observed value is 1. So there was difference between the calculated value and experimental value, but here is no difference. The de Broglie wavelength of neutron and proton are also consistent with nuclear dimensions. We show that proton and neutrons lies in the nucleus. So this also evident this hypothesis, proton neutron hypothesis. Explanation of beta particle emission. The electrons, this hypothesis is that electrons which were emitted in the beta negative decay, these electrons does not pre-exist in the nucleus, but it just formed at the instant of emission. and they are formed during a nuclear process with of conversion of neutron into proton. When neutron is converted into proton, then along with proton, two other particles, electron, which is also called beta negative particle, and antineutrino are also emitted. This above reaction is known as beta decay. The electrons which are emitted here have energy 2 to 3 mega electron volt when calculated by energy consideration of this process, and it is actually measured in the emission of beta negative particle, which was same as experimentally measured value. One other process, positron emission, was also observed, and it also explained according to this hypothesis. Positron is emitted when proton is converted into neutron. When proton is converted into neutron, positron, which is represented by E plus, and neutrino. Positron is also called as beta positive particle. These two particles along with neutron also emitted. Since proton and neutron are interconvertible, they can be regarded as two different states of single particle. Proton and neutrons are two different states of a single particle. In the above emission, two new particles, neutrino and antineutrino, were found to be emitted from the nucleus. Both these particles are neutral, massless, and spin half particle. Neutrino is emitted with positron emission, as we have seen in this reaction. Neutrino is emitted with positron emission, and antineutrino is emitted with electron emission. So, according to this hypothesis, the proton and neutron lies in the nucleus, and electrons equally in number with proton lies outside the nucleus. The number of proton which lies in the nucleus is called atomic number, which is represented by Z. The sum of number of protons and neutrons in a nucleus is called mass number and is denoted by A. Number of neutrons is represented by N. So A is equal to N plus Z. Number of neutrons plus number of protons. Isotopes. What are isotopes? Nuclei having same atomic number but different mass number are called isotopes. Isobars. Nuclei having same mass number but different atomic number are called isobars. Isotones. Nuclei having same neutron number are called isotones. Representation of nucleus. How nucleus is represented? A nucleus is represented by symbol X, and its mass number is represented as superscript and atomic number as subscript. A is its mass number and Z is its atomic number. And X is chemical symbol of element which have mass number A and atomic number Z. So let us move to the basic property of atomic nuclei. Here we will discuss the two properties, and other properties we will discuss in the next video. So let us start with first property, that is charge. The number of protons in a nucleus is equal to atomic number, and one single proton has positive charge E. So Z proton will have total positive charge plus Ze. So positive charge on the nucleus is plus Ze. Second property is mass. About 99.99% of mass of atom lies in the nucleus. Nuclear mass is determined by measurement of ratio of its charge to mass by mass spectrometer and with the help of nuclear reaction energy. How mass will be calculated? First, ratio of charge to mass is calculated by mass spectrometer, and then we consider nuclear reaction energy to find the mass. It always comes out to be very close to an integer denoted by A when expressed in terms of atomic mass unit. When mass is expressed in atomic mass unit, it always comes to close to an integer called which is denoted by A and called its mass. So 1 atomic mass unit is equal to 10 raised to power minus 3 by Na kilogram. Na is Avogadro's number. How it comes? We know that 1 gram of atom is equal to Na atoms. Na is Avogadro number. So mass of Na atom is equal to 1 gram, 10 raised to power minus 3 kilogram. So mass of one atom will be equal to 1 gram over 10 raised to power minus 3 kilogram by Na. So this is the mass of one atom, which is equal to one atomic mass unit. So one atomic mass unit is equal to 10 raised to power minus 3 by Na kilogram. And when we solved this by putting the value of Avogadro's number, 1.6604 into 10 to the power minus 27 kilogram will be the result. When we express it in energy units, mega electron volt, it will come equal to 931.4 mega electron volt. How it can be converted into energy units? We know that mass formula of energy is equal to mc square. M is the mass of atom and c is velocity of light. So mass is one atomic mass unit and multiplied by c square. One atomic mass unit is equal to 1.6604 into 10 to the power minus 27 kilogram. When expressed in kilogram, it is 1.6604 into 10 to the power minus 27. And C is 3 into 10 to the power 8. And it's scared. When we solved this, we found that 1.4922 into 10 to the power minus 10 joules will be the energy of one atomic mass unit. When converted into mega electron volt, it comes out to be 931.4 mega electron volt. The mass of carbon atom was exactly found to be 12 atomic mass unit. Uh, we we have said here that when mass is expressed in atomic mass unit, it comes close to an integer, which is its mass number. So when we express the mass of carbon atom in the atomic mass unit, then it exactly come at 12, come to be 12 AMU, which is its mass number. Practically, the total nuclear mass is equal to sum of mass of protons and neutrons constituting the nucleus. To find the total nuclear mass, we take the mass of Z protons and mass of N neutrons, and then we will add both of them. MP is mass of single proton, so mass of Z proton is Z into MP. Mn is mass of single neutron, so mass of N neutron is N into Mn, and then we will add the both values to find the total nuclear mass. Other properties we will discuss in the next video. Thank you.